So when we are capturing or injecting CO2 through CCS projects, it is important to know the composition of the stream that we are transporting. It will never be 100% CO2, and it is important to know what phase we are transporting it in at the pressure and temperature at which we are operating, and to know how this CO2 mixture stream will behave at different conditions. Okay, so this is the phase diagram for pure CO2, and what we see is that the separation between gas and liquid phases in the pressure temperature diagram is just a line. But as soon as we start injecting impurities, we will actually go more into a phase envelope. Inside this phase envelope, we will have both liquid and gas in equilibrium. So it is important to know at a given pressure and temperature where in the phase envelope we are. And if we are in a two-phase region, then what will happen is that we will have liquid and gas in equilibrium, and each one of these phases will have different compositions. That will tend to have a liquid phase that is enriched in CO2, but a second phase, a gas phase, that is richer in impurities. So if, for example, we're saying that for Northern Lights projects, we are talking about purities of CO2 of over 99%, if I happen to have impurities, which I will have, and I happen to operate at some point within this phase envelope, I will have a second phase that will be richer in other impurities. So it is important to understand where we are operating and how the fluid stream that I am operating will behave in order to operate safely and make sure that I don't have any damages downstream. So this is a CO2 mix. This is a phase equilibrium rig, and I think we can say that it has been our working horse. It's been active for more than 10 years, and the thermodynamics group in SINTEF has been kind of built around the results that we've had from this rig have been very successful. So if I have a CO2 rich mixture, CO2 plus one or two or more components, at a given pressure and temperature, we're able to very accurately measure how much is the concentration of each one of these components, both in the liquid and in the gas phase. And this allows us to then make more robust equations of state that are used by industry to be able to predict how the stream or the CO2 rich mixture will behave in their processes.